Hello and welcome to this tutorial on PI Expert version 9. In this tutorial, we will walk you through a basic LED driver design using the LinkSwitch-PL. Let's start off by selecting the LinkSwitch-PL family of devices. Let's select the D package for this design. The enclosure is a way of specifying the thermal environment of the power supply. In this case, we want to design a driver for a lamp replacement prototype. So let's select the lamp retrofit selection. For other designs which may offer more forgiving airflow, you should select the open frame selection instead. By default, LinkSwitch-PL uses direct secondary side feedback to sense the driver current. It is a non-isolated flyback topology. Click Next. This takes you to the AC-DC input type dialog. On this dialog, you can specify the input voltage range and the frequency if applicable. For DPA switch applications, you can choose the input range from this low voltage DC input selection. LED drivers rarely use the universal input range. Since I intend to use this prototype in a 230 VAC application, I will select this option. This dialog also allows you to specify whether or not you want to support Triac dimming capability. Let's check this box. Click Next. On the DC Outputs dialog, you can specify the output voltage and current by clicking this Add button. Let's specify a voltage of 12 volts at 0.35 amps. Click OK. Click Next. In the Design Settings dialog, you can specify which component set the software should use during optimization. The default component set contains components that were included in the software during installation. As you add more and more components, these will be automatically included in the All Records component set. Let's leave the All Records component set for this design. In addition to other controls on this dialog, you can also specify the units, American or SI, and ask the software to use shield windings while coming up with the solutions. Let's check both these boxes for this example, and then click Finish. The Solutions Filter dialog allows you to specify how many solutions you want the software to remember and present to you at the end of the optimization run. You can also specify what combination of turns and core sizes you want the software to try out. I generally leave the turns range untouched. By default, the software has enough range of turns that it will not miss out any viable combination. It is possible to force the software to optimize with a given core size. This is covered in a separate tutorial. Click OK. This starts the optimization process. After optimization is complete, a list of top solutions is presented to you, the best design on top. You can select the fields you want to see for comparing the solutions by clicking the Fields button. You can move the variable order by using the up and down controls. Select the solution you want to view for detailed information and click Open. I am going to select Solution 5 because I want to see an optimized design using an RM core. Click Open. The schematic view shows a complete schematic of the power supply with standard component values. You can double-click on a component to change it directly from the schematic. Or you can right-click on a component and open the functional dialog to make changes. The Design Results tab lists detailed electrical parameters related to the input section, PI device variables, clamp circuit, transformer parameters, and output parameters. You can make changes directly from this form just like you would in a PI XLS spreadsheet. For example, I can change the secondary number of turns, NSM, from 6 turns to 5 turns directly from this form. Notice how the fit factor, FF, changed from 42% to 36%. Also notice that as a result of this change, the peak flux density increased to 410 millitesla. This has also been highlighted as a serious problem in the summary box at the bottom. You can always press the undo button to reverse manual changes. All the components are listed along with the manufacturer part numbers on the BOM tab. There is also a button you can click which then uploads the BOM to a web application that matches the manufacturer part number to a distributor like DigiKey or Mouser. But more on that in a separate tutorial. There are layout recommendations in the Board of Layout tab. If you click on the Show Me column, the relevant sections highlight so you can focus on the specific area that is being referred to. Finally, there is a detailed transformer construction form which lists everything that is required to build a transformer prototype. There are electrical and mechanical build diagrams and winding instructions that specify exactly how the transformer should be wound and tested. We do hope that this tutorial has been helpful to you in getting a jump start, and we hope it will prove useful to you in your designs. Good luck.